Hello everyone, I'm THAM HUI MING, a final year student from USM. Today I would like to present my research final thesis on sentiment classifications of English-Malay code switching opinionated text on social media. Malaysian Twitter users often rely on tweets for making purchasing decisions. As Malaysia is a multicultural society, Malaysians often practice English and Malay code switching when expressing thoughts on social media text. However, manually reading and understanding mountains of code-switching tweets is very burdensome for both sellers and customers. Hence, automated sentiment classification comes in to help customers in deciding quickly, besides expanding our Malaysian local brand businesses. In this study, we focus on sentiment classifications of English-Malay code-switching tweets of a local Malaysian brand Dedak Group. There are two issues in code switching text sentiment classifications. The first issue is the existence of informal Malay words such as Malay abbreviation and slang words. In lexicon-based approach, the informal Malay words that are unable to be found in the dictionary will either be removed or simply assigned to neutral polarity. And neglecting of these opinionated informal Malay words will lead to misclassifications of the sentiment of the whole text. The same goes to the machine learning approach. The informal Malay words that express in non-standard or different canonical form will also impact the learning of model and decrease accuracy in sentiment classification. The second problem is the current work only focus on the lexicon-based and rule-based system. For instance, some researchers construct lexicons and use together with some grammar rules or balance shifter rules to classify the mixed language text. However, this work requires deep expert knowledge to identify all the balance shifter words and building the lexicons. Besides, it's very time consuming and requires a huge dataset to perform testing and analysis. According to the research problem statement, the main objectives of the research are to improve the English-Malay code switching text sentiment classification by normalizing the informal Malay words, and to compare different supervised machine learning methods on English-Malay code switching text sentiment classification. Next is the research methodology part. The dataset we use in this research is a raw tweet dataset that contains 2,416 tweets written in English, Malay, and English-Malay code switching. As our research only focused on the code switching tweets, pure English and pure Malay tweets are filtered out, and the remaining 1,478 code switching tweets are passed to the human annotators for sentiment annotations. For example, -1 value is for negative tweets, 0 is for neutral, and 1 is for positive tweets. And total 3 human annotators are involved in the annotations, and the inter-agreement kappa value is calculated. This is a sample of the tweets annotations. Example, we have -1, the negative tweets, the neutral tweets, and also the positive tweets. 1,478 code switching tweets is split into the testing and also the training dataset. Then we continue with our proposed normalizations of informal Malay words method. We have proposed two normalization methods, which the first method is using existing Malay electoral transformer installer to correct the Malay abbreviations and typo. And the second method is using both Malay electoral transformer installer and also the constructed informal Malay word lexicons to normalize both Malay abbreviations and also slang words. So we have two methods to construct a lexicon. First method is using our training dataset, and the second method is using the Zaina and Fakuha informal collection. And total 3 lexicons are constructed. These are some examples of the informal formal Malay word pair in our word lexicon built from the training dataset. And this one is the example of word pair in the lexicon built from Zaina informal collections. And the third one is the example of word pair in the informal lexicon that built from Fakuha collections. So the constructed lexicons will be combined and used together with the Malay library to normalize the informal Malay word. For example, we combine constructed lexicons. So after constructing and combining lexicons, we continue with normalizations or substitutions of the informal Malay words For example, first we read the contextual lexicons into a dictionary with the key and value pair, which the left part, the informal Malay word, will be the keys, and the right part, the formal Malay words, will be the values. And then we substitute the informal Malay words with formal Malay words in the dictionary. For example, if the words in the twin dataset can be found in the dictionary, then the word will be replaced with the dictionary value, which is the formal word. So this one is before substitutions using our lexicon. We still have the abbreviation nak and dah. They cannot be normalized by Malaya. So after we using our lexicon and substitute it, the abbreviation nak is replaced with hendak and dah is replaced with sudah. So next is our view of our proposed classification framework. And our framework can be divided into two. And this one is the first sub-framework, which is to compare different informal Malay word normalization method in sentiment classification. So in pre-processing stage, different normalization methods are applied and the pre-processed data are kept as different dataset file. So from here you can see we have 5 different normalization dataset file being compared. And the first one is the baseline dataset, which the dataset being pre-processed without any informal Malay normalization. And the second one is the Malaya normalization dataset, which dataset being pre-processed with Malaya library. And the third, fourth, and fifth dataset are dataset that being pre-processed using both Malaya library and also the constructed combined lexicons to normalize the abbreviations and also the slang word. So one here refers to the lexicon built from the training dataset and also the China informal collections. And 2 here refer to the lexicon built from training dataset and also the Fakuha informal collections. And 3 here refer to lexicon built from training dataset and also the both China and Fakuha informal collections. And each dataset consists of both training and testing dataset, and the accuracy of supervised machines for all the 5 normalization methods are being compared. So this is our detailed pre-processing stage. First, we lowercase the tweet text, then we remove the HTTP and HTTPS URL link, and remove the username, replace the emoji with equivalent words, and remove the digit or numbers, expand the English contractions, and remove the special character. Then we remove all the single character except the character X, as the X means tidak in tweets. Then we apply our normalizations method. So after proposed normalization methods, we apply stemming and lemmatization on the English and Malay words, and then followed by removing both English and Malay stop words. So after all this pre-processing stage, different normalized training and test dataset are produced. And then we continue with the tokenization to tokenize the tweets into a list of words before using call vector for feature extraction. So this one is our second sub-framework, which is optimized performance of learning model with high parameter tuning, as well as compare and find the best feature extraction method and learning model in sentiment classification. So after comparing different normalized dataset, Malaya plus 3, which give the highest accuracy in sentiment classification, is selected as the input for our second sub-framework. And in this sub-framework, different feature extraction methods and also learning model are compared to find the best machine learning method in the code switching sentiment classification. So the feature extraction methods compared are TF-IDF, call vector, Boolean vector, and also chi-square. And whereas the learning model we compare are the naive Bayes, supervised machine, random forest, and logistic regressions, and also the example of each learning classifier. Besides that, we also perform the hyperparameter tuning on the learning model, and each optimized learning model is compared with its default model before combining using the example algorithm. Random search and also the stratified tenfold cross-validations are used for hyperparameter tuning in this sub-framework. Details for our sub-framework 2. First, we perform hyperparameter tuning for our 4 learning models in 4 feature extractions. Then we compare the output from step 1, which is optimized learning model, with the default learning model to find the best estimator. And after that, we assemble our combinations of a best estimator using a voting algorithm. And then we compare and find the best feature extraction method and also learning model. So the next part is evaluations of a proposed informal Malay word normalization. So four different normalization methods are being evaluated here, and the performance metric used is accuracy. So the accuracy can be calculated as number of TT divided by number of TT plus TF and FT multiplied with 100%. So TT here refers to the correctly annotated or normalized word by our proposed normalization method, whereas FT here is a wrongly annotated or normalized formal word by the proposed normalization method, and TF here refers to misannotated or normalized formal word by the proposed normalization method. FF is the correct formal word, so it's not considered in calculations. Next is the result and evaluation part. The first experiment is normalizations of informal Malay words for sentiment classifications of English and Malay code switching tweets. In this experiment, we compare accuracy of support method machines on different normalization datasets. And from the result, we can see that our baseline dataset give a 0.51 accuracy score, and after using the Malaya NLTK library, the accuracy increased 2%, which is 0.53, and the highest accuracy score, 0.54, is achieved by using Malaya and the combinations of the three constructed lexicons. Next, this experiment evaluate proposed normalization methods in correctly normalizing the informal Malay words. And the evaluation is performed based on the 50 code switching tweets that randomly selected from our testing dataset. And here, the number of annotated words is referred to number of TT, TF, and FT, whereas the number of correctly annotated words here is referred to number of TT. So, from the result, we can show that the Malaya plus 3, which is the combination of all the three lexicons, achieved the highest accuracy, 47.8%, in correctly normalizing the informal Malay words in the new code switching tweets. Next is the result for supervised machine learning method selections for sentiment classifications of English and Malay code switching tweets. This is a result of comparison among the best learning models with the best hyperparameter combinations in every feature extraction method. From the result, we can know that the count vector, Boolean vector, chi-square, is better than the TF-IDF feature extraction method as accuracy of the best learning models are higher than the TF-IDF best learning model. Among the 5 best classifier, example of NB SVMRF with the count vector and example of NB SVMRF with the Boolean vector are the best machine learning method in classifying the negative and positive code switching tweets, as both of them give the highest F1 score in the negative and positive tweets. Whereas the example of SVM, RF, and LR with count vector is the best machine learning method in classifying the neutral class code switching tweets. Average F1 score is calculated for all the three sentiment classes, and the results show that MB, SVM, RF, and SVM, RF, LR with count vector, as well as the MB, SVM, RF with Boolean vector are the best machine learning methods in classifying the English and Malay code switching tweets into positive, negative, and neutral classes. Next is the overall analysis result and limitations. So the best normalization method is Malaya plus 3, which is Malaya and the combinations of the three constructed lexicons. And the count vector is the best feature extraction method in our study, as it has the largest number of best learning models that give the highest accuracy score and also the average F1 score. Besides, support vector machines is the best individual learning classifier. And the best machine learning methods are listed as follows. So we have the count vector with the example of the machine learning model, and also the Boolean vector with the example learning model. My research contributions are normalizations of informal Malay word method, such as the Malaya transformer speller and informal Malay word lexicons. The result proved that both normalization methods can normalize the informal Malay and increase accuracy in sentiment classification. The second contribution is the benchmark training and testing dataset for the dark group with sentiment value -1 for negative tweets, 0 for neutral tweets, and 1 for positive tweets. Third, this research is the first pair research that use and compare different machine learning methods in English-Malay code switching sentiment classification. Different feature extraction technique and machine learning methods are compared in this study. And the additional contribution is we extract and write the differences of words as per highlighted in the WinMerge HTML report into a CSV file. And this can be used for other purposes such as tracking or recording the differences between two files. Thank you.